Welcome back to Tech Margadarshi. In this video, we'll continue our Java beginner program series with number-based programs like reverse number, palindrome, Armstrong, perfect number, and more. Let's strengthen our Java logic and coding skills together. Let's understand how to reverse a number in Java. First, we take the number 1, 2, 3, 4, and 5 and initialize a variable reverse with 0. We use a while loop to extract each digit from the number. The modulus operator %10 gives us the last digit. We then add that digit to reverse after multiplying the existing value by 10. Finally, we use integer division by 10 to remove the last digit from the original number. This process continues until the number becomes 0. For 1, 2, 3, 4, 5, the reverse number will be 5, 4, 3, 2, and 1. This program is important for understanding loops, modulus, integer division, and number manipulation in Java. Now, let's understand how to check whether a number is a palindrome in Java. A palindrome number is a number that remains the same when it is reversed. For example, 121 becomes 121 when reversed. First, we store the number 121 in the variable num and keep a copy of the original number in original num. We then reverse the number using the same digit extraction logic we learned in the previous program. After reversing the number, we compare the original num with the reverse value. If both are equal, the number is a palindrome. Otherwise, it is not a palindrome. In this example, 121 and its reverse are the same. So the output will be 121 is a palindrome number. This program is commonly asked in Java coding interviews and helps strengthen number manipulation logic. Now, move on to next one. Let's understand how to find the sum of all digits of a number in Java. In this example, we take the number 1, 2, 3, 4, 5 and initialize a variable sum with 0. We use a while loop to extract each digit from the number. The modulus operator %10 gives us the last digit. We then add that digit to the sum variable. After that, we divide the number by 10 to remove the last digit. This process continues until all the digits are extracted. So for 1, 2, 3, 4, and 5, the calculation is 1 plus 2 plus 3 plus 4 plus 5, which gives us 15. This program is a good example of using modulus and integer division for digit manipulation in Java. Now, next one to understand how to count the number of digits in a number using Java. In this example, we take the number 1, 2, 3, 4, and 5 and initialize a variable count with 0. We then use a while loop. In every iteration, we divide the number by 10. This removes the last digit from the number and we increment the count by 1. The loop continues until the number becomes 0 for 1, 2, 3, 4, and 5. The loop runs 5 times, so the total number of digits is 5. This program helps us understand integer division, loops, and how to process individual digits of a number in Java. Now, next one. Let's understand how to find the largest digit in a number using Java. In this example, we take the number 5, 8, 3, 2, and 9 and initialize a variable largest with 0. Using a while loop, we extract each digit using the modulus operator modulo 10. We then compare the extracted digit with the current value of largest. If the digit is greater, we update largest with that digit. After checking every digit, the largest digit is stored in the largest variable. For the number 5, 8, 3, 2, and 9, the largest digit is 9. This program helps us understand digit extraction, comparison, loops, and logical problem solving in Java. Now, let's understand how to find the smallest digit in a number using Java. In this example, we take the number 5, 8, 3, 2, and 9 and initialize the smallest variable with 9 since 9 is the highest possible single digit. Using a while loop, we extract each digit using the modulus operator modulo 10. We then compare the extracted digit with the current value of smallest. If the digit is smaller, we update the smallest variable. We continue this process until all the digits have been checked. For the number 5, 8, 3, 2, and 9, the smallest digit is 2. This program helps us understand digit extraction, comparison, loops, and logical problem solving in Java. Now, let's understand how to check whether a number is an Armstrong number in Java. An Armstrong number is a number where the sum of the cubes of its digits is equal to the original number. For example, 153 is an Armstrong number because 1 cubed plus 5 cubed plus 3 cubed equals 153. First, we store the number 153 and keep a copy of it in original num. We then use a while loop to extract each digit using the modulus operator. For every digit, we calculate its cube and add it to the sum. We then remove the last digit using integer division by 10. Finally, we compare the calculated sum with the original number. If both are equal, the number is an Armstrong number. In this example, the output will be 153 is an Armstrong number. This program is a very common Java coding interview question and is useful for understanding loops, digit extraction, and mathematical logic. Now let's understand the last one of part 3 series. That is how to check whether a number is a perfect number in Java. A perfect number is a number whose sum of all its proper divisors, excluding the number itself, is equal to the original number. For example, the proper divisors of 28 are 1, 2, 4, 7, and 14, and their sum is 28. First, we declare the number 28 and initialize the sum variable with 0. We then use our for loop to find all the divisors of the number. Whenever the number is completely divisible by I, we add I to the sum. We only need to check up to half of the number because no proper divisor can be greater than half of the number. Finally, we compare the calculated sum with the original number. If both are equal, the number is a perfect number. In this example, the output will be 28 is a perfect number. This program is useful for understanding loops, modulus operators, divisors, and logical problem solving in Java. That's all for Java Beginner Programs Part 3. Practice these number-based programs to strengthen your Java logic and problem-solving skills. Don't forget to like, share, and subscribe to Tech Margadarshi for more Java coding programs.